This conference will now be recorded.
Hello guys, today we'll speak about how to form an ions, how to write down the formula for ionic compounds, and what is generally ionic bonds. Before starting with ions, you have to know about the structure of an atom. As you know, atoms are having the same number of protons and electrons. But when it comes to the ions, the number of protons and electrons are not the same. Generally, ions are atoms or group of atoms with a positive or negative charge. In order to determine how many electrons do atoms have in their outer shell, we have to take a look at their position in the periodic table. As you know, the group number is showing us how many electrons do they have in their outer shell. For example, in case of hydrogen, it has 1 electron in its outer shell, and it's located in group 1. In case of sodium, it also has 1 electron in its outer shell, and it's also located in the first group. When it comes to the carbon, it has 4 electrons in its outer shell, and that is why it's located in the fourth group. In case of group 8, they have 8 electrons in their outer shell. The only exception here, we are having helium, which has only 2 electrons in its outer shell. It's due to the presence of the maximum electrons that each shell can hold. In case of first period, you know that we are having only one shell. And this first shell, as you can see here, in case of each atom, they can hold just 2 electrons. That is why helium has only 2 electrons in its outer shell. But all other noble gases, they are having 8 electrons in their outer shell. According to the octet rule, atoms tend to gain, lose, or share electrons in order to have 8 electrons as in noble gases. For example, if carbon, which is located in the fourth group, has 4 electrons in its outer shell, it would like to gain 4 electrons, to have 8 electrons as in case of neon. Or in case of nitrogen, if it is located in the fifth group, it means that it would like to gain 3 electrons, while oxygen is located in the group 6 and it will gain 2 electrons in order to complete its outer shell. As you can see from periodic table, the closest noble gas to carbon, nitrogen, and oxygen is neon. And that is why carbon, nitrogen, oxygen, they will try to have the same electron configuration as neon. In order to do it, they will gain an electron. Commonly, ions are having the following charges. First group elements are having +1 charge. Second group elements are having +2 charges. You have to know that metals generally tend to lose an electron, and that's why we are calling them cations. When it comes to non-metals, they tend to gain an electron, and that is why they are having negative charge. Due to this fact, we are calling them anions. Generally, by losing or gaining electrons, atoms has the same number of electrons as nearest group 8 elements. Let's check ourselves. Here we are having potassium ion. As you know, the number of protons are the number of electrons are equal in case of neutral atom. When it's turning to the ions, the only thing that is changing here is the number of electrons. In case of potassium ion and potassium atom, in case of both of them, they are having 19 protons. When it comes to the neutrons, from the previous lessons, you have learned how to calculate the number of neutrons. You have to subtract atomic number from its atomic mass, so you will have here 20 neutrons. And when it comes to the number of electrons in case of ions, due to the presence of +1 charge, we should have here 18 electrons, as 1 electron already lost by potassium atom when it's turned to the potassium ion. When it will come to the oxide ion, we are having 8 protons, as it's shown 8 here. We are having 8 neutrons because protons number subtracted from atomic mass, and we are having here 8 neutrons. And if we want to find out the number of electrons, we have to pay attention to the charge. We have here -2, so we should have here 10 electrons, as 2 electrons already gained and added to the earlier presented 8 electrons. In case of calcium ions, we are having here 20 protons, we are having 21 neutrons, and we are having 18 electrons. Remember that an electron is negatively charged. When you lose them, an atom becomes a positively charged ion, as the number of protons more than the number of electrons. But when you are gaining an electron, you are gaining negatively charged species, and that's why the number of electrons will be more than the number of protons, and overall charge will be negative. But what about ionic bonding? Ionic bond formed between two ions by the transfer of an electrons. In ionic compounds, one or more electrons are transferred from one atom to another. The resulting cation and anion are strongly attracted to each other and are held together by an ionic bond, resulting from electrostatic attraction forces. If you will take a look at the structure of sodium and chloride ions, you will see that they are forming electrostatic attraction forces, which is called ionic bond. If you have close look at this picture, you can obviously see that initially in sodium atom, you had one electron in its outer shell. And in case of chlorine atom, you had 7 electrons in its outer shell. Sodium atom is trying to complete its outer shell by losing one electron. And where this electron will go? This electron will go to the outer shell of chlorine atom. And chlorine atom is trying to complete its outer shell by gaining one electron to have the same electronic configuration as in case of argon. Overall, you are having sodium ion and chloride ions are formed. And the attraction forces between the sodium ions and chloride ions is called ionic bonding. What about the properties of ionic bonds? You have to know that ionic bonds are formed between metals and non-metals with very different electronegativity. From metals, they will form cations. From non-metals, they will form anions. And overall ionic bond is electrostatic attraction forces between cations and anions. Bond formed due to the presence of transfer of an electrons, and they are producing charged ions in all states. Also, it's important to know about their physical properties. Ionic compounds are good conductors of heat and electricity while they are molten or in aqueous state. Aqueous state means that when they are dissolved in the water. As you know, ionic bonds are soluble. You can dissolve them in water, and in that case, you are getting aqueous solution. And also, they have really high melting points. You need a huge amount of an energy in order to break down ionic bonds in case of ionic compounds. And examples such as sodium chloride, calcium chloride, or potassium oxide. If you will take a look at the structure of sodium chloride, table salts that you are eating at home, you will see cubic structures. Generally, sodium chloride is not only made up from sodium ions and chloride ions. Generally, in case of salt, so table salt, sodium chloride, it has a giant lattice structure. But in order to make things more easier, they are just representing the atoms that are presenting there. But if you will take a close look at the structure, you will see that each sodium ion is surrounded by 6 chloride ions, and each chloride ion is surrounded by 6 sodium ions. This is how the ionic lattice structure is constructed. And how do we write down the formula for ionic compounds? The ions present in an ionic compound can be in two forms, monoatomic and polyatomic ions. When it comes to monoatomic ions, it's easy to write down their formulas. You have to write down a charged species containing a single atom that has gained or lost electrons. In case of aluminium, it has located in the third group. That's why it has 3 electrons in its outer shell. While it will lose 3 electrons, we have to write down Al3+. When it comes to the sulfur, it has located in the group 6. And in order to have 8 electrons, it should gain 2 electrons. That's why you are having 2 minus. But when it comes to the transitional metals, they have different charges. In order to know which charge do they have, we have to use brackets. When we are having iron 2 ion, we are writing in a brackets 2. When we are having iron 3 ion plus ion, we are writing in a brackets 3. But when it comes to the anions, we have to change their namings. Monoatomic anions are named by dropping the ending of the element's name and adding IDE. For example, in case of nitrogen, it will become nitrite, and in case of oxygen, it will become oxide. You are responsible for knowing the names and formulas of all ions listed in your syllabus, including the common polyatomic ions. The only polyatomic cations that you have to know is ammonium ion. But you have different types of polyatomic anions. Which ones are here, like as hydroxides, nitrates, sulfates, carbonates, or phosphates. While you are writing the formula for ionic compounds, you have to always take into consideration that the number of positive charges should equal to the number of negative charges. Overall, the ionic compound should be electrically neutral compound. For example, in case of sodium chloride, you have 1 plus 1 charge and you have 1 minus charge. Overall, it has 0 charge. When it comes to the calcium chloride, because calcium has 2 plus charge and chloride has 1 minus charge, in order to make it electrically neutral, you should have 2 chloride ions. So the formula of calcium chloride will be CaCl2. Or in case of when you are writing with polyatomic anions and cations, you have to know that the charge which is written on the top of polyatomic anions and cations belongs to both of the atoms, sulfur and oxygen. Or here, -1 charge belongs to hydrogen, carbon, and oxygen. So in order to write down the formula of calcium sulfate, calcium 2 plus and sulfate 2 minus, overall electrically neutral, it will be calcium sulfate, CaSO4. When we are writing the formula, you also can use this method. In case of magnesium, it has 2 plus charge. In case of nitrite ion, it has 3 minus charge. 3 comes here and 2 comes here, Mg3 and 2. When we are writing the formula with polyatomic anions, you have to pay attention that when we are writing 2 here, this 2 should belong to both of them, oxygen and hydrogen, and that's why we are taking them in a bracket and writing down 2 here. But 1 should come here. Generally, we are not writing down 1. Doesn't matter if you are having +1 charge or -1 charge. This is the formula which is given for you in order to check yourself and try to write down. But while you are writing, please pay attention that iron here has +2 charge, as in the brackets it's shown 2. And when you are writing magnesium hydroxide formula, you have to take in a brackets OH minus group. Good luck to you guys. Bye.